Okay, so we're going to go over the answers for the January 2017 Regents, questions 25 until 32. So for number 25, what you have to do here is express this in simplest a plus bi form. So a plus bi form, that's a complex number. So it has a real number and an imaginary number, where I is the imaginary number. So first, remember, you're not just cubing each part. You have to rewrite this as 1 minus I, 1 minus I, and then 1 minus I. You can only multiply two things at a time, so then I'm going to double distribute the second half. You can double distribute the second two. You can double distribute the first two if you want, doesn't matter. So I still have to multiply 1 minus I times, this becomes 1 minus I plus I squared. So this is 1 minus I times 1 minus 2I, and then we have this I squared. Remember, your really important rule for imaginary numbers here is that I squared is equal to -1. So this is -1. So these two cancel out, so now I just have 1 minus I times -2I, because here the 1 and -1 canceled out. So this becomes -2I plus 2I squared. Again, I squared, this is -2I minus 2. The only thing is that because this says a plus bi form, it should be in -2 minus 2I as your answer. You want your I value to come second. And that's it for number 25. For 26, an orange juice processing plant receives a truckload of oranges, and then they're randomly choosing 3 pails of oranges, with each containing 50 from the truckload. Identify the sample and the population. So the sample is exactly what it sounds like. It's a sample of the whole thing. So this wants me to identify the sample and the population. So the population size here, the population comes from the truckload. So the population is the truckload of oranges. The truckload. Okay, and then the sample are the 3 pails that they're choosing. So the sample is the 3 pails of oranges. Okay, so like for example, if I'm talking about the population of my Algebra 2 classes, I have 3 Algebra 2 classes, but if I'm talking about a sample of them, I might only choose period 2, or I might only choose period 4, or period 7. But each individual one is a sample of the whole population of those 3 classes that I have. So now the second part of this question wants me to state a conclusion that can be made about the population. So about the population, if 5% of the sample is unsatisfactory. So if 5% of the sample is satisfactory, then it's likely, so you could say for your conclusion, it is likely or usual, we would say in class, it is likely that approximately, you can't say exactly, that approximately 5% of all, this all here is the population. So it is likely that all, so the population of the oranges are unsatisfactory. Okay? All right, so 27 deals with some trig stuff. So using the unit circle below, explain, so you have to use words, explain why the cosecant of theta is equal to 1 over y. So right away, you should recognize that the cosecant of theta is the reciprocal of sine of theta. So right away, you can say cosecant of theta is equal to, remember, reciprocal is when you flip it, so it's equal to 1 divided by the sine of theta. And now remember, we're on the unit circle, so because we're on the unit circle, we have that rule that says that the sine of theta is equal to the y value of whatever that point is right here. So the y value here, this is really cosine theta comma sine theta, because cosine is x, sine is y. Okay, so it's equal to the y value of that point, if you want to say. So because sine of theta equals y, and cosecant of theta is 1 over the sine of theta, we also can say that the cosecant of theta, this is using substitution, the cosecant of theta is equal to 1 divided by y, okay? For number 28, the function m of t represents the mass of radium over time, t in years. So this has this whole long nasty function here, and it says determine if m of t represents growth or decay. So remember, growth is when it goes up, and decay is when it would be going down. Okay, so explain your reasoning. So again, this is another explain, so you have to use your words. So what you can do, what I suggest that you do, is go into your calculator, plug this function in. You see this nasty fraction here, use alpha y equals to plug it in just to be sure. And what you can do once you have that plugged into your calculator is you can list, remember this is t and m of t. So your x term is really t and then m of t. You can list some values in your calculator. So you can say 0, 100, 1 is 99.956, 2 is 99.913, 3, 99.869, and you could say 4 is 99.826. This isn't enough though for your work. Okay, you have to say then, as the values of t are increasing, as your values of t are increasing, m of t is decreasing. Okay, so what you would say is m of t decreases as t increases. So as t is going up, m of t is going down. So you also have to say what that means. So m of t represents, that's a t, not a d, represents decay. Okay? It's not enough just to have this. You also need to have this then. You need to show some work as to where you came to your answer. You want to show them as much as possible. That way they can say without a doubt that you know what you're talking about. 29 is a graphing question, so you're going to have to look to those graphs that are in the back of your packet, and then you're going to cut out whatever grid you use and tape it into the box labeled 29. Same thing with if you have to correct your answer, then you're going to go through this on another graph, and you're going to have to tape that one in as well. Remember, your graphs should be done in pencil because that's how they're going to be done in June. Okay, your graphs have to be done in pencil. Everything else can be in pen, I don't care, but your graphs have to be in pencil. You have to get used to graphing in pencil. Alright, so on the grid below, so I just labeled my axes too, sketch a cubic polynomial whose zeros are 1, 3, and -2. So a cubic polynomial, if you remember, these are your graphs that'll either go like this or you can flip it around and it'll go like this. Okay? So, my zeros are at 1, 3, and -2. So if you want to label those, here you have -2, here you have 1, here you have 3. Okay, you don't have to label all of them, but you should label something. So even if you just come here in -1, here in 2, whatever you want to do. Okay, so really this is more of an open-ended question because you can choose to go either way. You can either start up and then come down right away, or you can start down and come up. It doesn't matter. Okay, but your arrows, because this is a cubic, if you remember end behavior for odd degree polynomials, right, degree meaning the exponent, here this is an x to the third. So whatever this happens, your end behavior, meaning the arrows here and here, they should be going in opposite directions. Okay, it doesn't matter for this question which way they go. So whichever way you come, just make sure that you're not going too far past that point here. So if you come straight here and you pass through 1, and then you keep going and you have to pass through 3, and then you go a little bit past and you draw an arrow. So this would work, or you could say this green here would work. If you come a little bit past here and you come in this way and out that way. Either one of those two graphs would work. You can't have both of them, obviously. You can only have one of them. Okay, but either of those would work. And this is not asking you to write the equation or anything like that. This is all that it wanted you to do. It just wanted to know that you know what zeros are. Okay, question 30. Given the equal terms, so the cube root of x to the 5th and y raised to the 5/6, determine and state y in terms of x. So this is asking me, this means here, solve for y. Solve for y in terms of x. So this says given the equal terms. So right away, I can write this, the cube root of x to the 5th is equal to y raised to the 5/6. So what I am going to do, because I can't, no radicals. We want to get rid of any radicals that we see. This is really x raised to the 5/3 power is equal to y raised to the 5/6 power. Okay? We're solving for y. So if you remember, we did this a while ago. To get y by itself, when it's being raised to a fractional exponent, you're going to get y by itself, which it is, okay, with the exponent. You're going to get the base and the exponent isolated. And then you can raise both sides to the reciprocal power of whatever you want to get rid of. So here I want to get rid of 5/6, so I'm going to raise this to 6/5. The reason being that these all cancel, and this becomes y to the 1st. Okay, which is what I want. So this is equal to x raised to the 5/3, also raised to the 6/5. So power to power means that we multiply. So 5 times 6 is 30, divided by 15. 30 over 15 is this. So determine and state y in terms of x. This is y equals x squared. And that's it. For number 31, the results of a survey are shown below about television preferences in a high school. So this is asking me, given this two-way table, are the events, student is a male, so I'm going to highlight that. Student is a male. And students prefer reality series right here. Are they independent of each other? So remember, I'm going to need the total amount here also. So remember, so you can state that two events are independent if the probability of both of them together is equal to, the intersection is equal to the probability of each individual one being multiplied together. So I need to see if the probability of M and R, I need to see if these are equal. The probability of M times the probability of R. Okay? The probability of the intersection. So how many, out of the 490 students, how many of them are males that like reality series? So they intersect at 70. So this is 70 over 490. We want to see, is that equal to the probability of male is 230 out of 490 times the probability for the reality series is 180 total out of the 490. Okay, so this left side here, this simplifies to be 1 over 7 in my calculator. Is that equal to whatever this is being multiplied together? So I type that into my calculator, and I get 414 out of 2401. These are not equal to each other. So that means, so we would say, so these events, you have to answer the question. You can't just show this work up here. So these events are not independent of each other because the probability of M intersect R is not equal to the probability of M times the probability of R. So this last question of this section deals with long division, which we've been doing for the past few months now. So given f of x and g of x, state the quotient and remainder of f divided by g in the form q of x, which is your quotient. This is your quotient, so what you get on top, plus the remainder divided by the divisor. So it's basically what we've been doing all along in class. When I rewrite this, so we have 3x squared plus 7x minus 20 divided by x minus 2. So this is nice, again, because here I don't have anything missing. I don't need any placeholders. So I need to see. So 3x squared goes into, x goes into 3x squared, 3x times, so this is 3x, I put it on top of the x term. So now I would do 3x times x, and I get 3x squared minus 6x, put it in parentheses, subtract it. 3 minus 3 cancels out. 7 minus negative 6 gives me 13x minus 20. So now I need to see how many times does x go into 13x, and I get 13. So this is plus 13. So 13 times x is 13x. 13 times negative 2 is negative 26. Put it in parentheses, subtract it. 13 minus 13 cancels out. Negative 20 minus negative 6. Keep change. So negative 20 plus 26 gives me 6. X can't go into 6 at all, so this is my remainder. So this is plus 6. Because this is positive, so plus 6 divided by x minus 2. So my final answer, so this is what it wants. My final answer is 3x plus 13 plus 6 divided by x minus 2. Okay, and that's it. So remember, this is going to be due on Monday, and it counts as a quiz grade. All of your readings exams put together are going to count as a quiz grade. Okay, if you have any questions, feel free to email me. You should be doing this weekend the June 2017 Regents exam, numbers 1 through 12, on your new packet. Okay, have a great day.